Well, here we are in West Virginia. Maybe not. Anyways, joke of the day. So, in light of where I am, how do you think the unthinkable? Well, with an iceberg. Anyways, let's sink ourselves into dividing rational expressions. So, we've talked many times about what rational expressions are, and recall, rational does not mean rational dude, it means fraction. And so these are complicated fractions that have more than just a number in the numerator, more than just a number in the denominator. They have polynomials in the numerator and polynomials in the denominator. But recall, they are just fractions. So therefore, when we're dividing rational expressions, it's just like dividing fractions, basically. So we need to recall what it takes to divide fractions. So for instance, if I had the fraction 2/3, and I was going to divide it by the fraction, let's say 4/9, what would it take to do that? Lots of people say copy, change, flip. Lots of people say I'm going to multiply by the reciprocal of the second. And basically what that indicates is I'm going to keep that first fraction as it is. I'm going to change this to multiplication, and I'm going to flip that second one. And notice that when I flip that second one, it goes back to a multiplication problem. And remember, when you multiply fractions, there's that gang symbol, yeah, which means I'm going to cancel on those diagonals, I'm going to cancel up and down, and I'm going to shoot straight across. So if it's just like dividing fractions, what that means is I'm going to multiply by, and let me get this out of here so I've got myself plenty of room to write, by the reciprocal of the second. In other words, what that indicates is copy, change, flip, and then like I said, once you do that, you have gone right back to your multiplication rules. So that would indicate the second step, which kind of isn't a step, but I'm going to go back to multiplication rules. So if that's the case, then that means that when I see this first example, and we're going to take a look at two examples, that means in this first example, I've got, yes, it's a complicated fraction here, and yes, this is a complicated fraction, but they are just fractions. So since I'm dividing the two, that means I'm going to copy, change, flip. I'm going to write down that first fraction as it is. Don't change a thing. I'm going to change it to multiplication, and I'm going to flip that second one. And when I do, I go back to my multiplication rules. So I'm going to take the reciprocal of the second, and it takes it right back to those multiplication rules, which again means cancel on those diagonals, cancel up and down, and then shoot straight across with multiplication. But recall, the only thing that will cancel is factors. Factors are things that are multiplied together. So I need to factor the numerator, denominator, and then I can go canceling. So recall that when you factor, the first thing that you do, you always look first to see if there's something common that you can divide out before you do anything else. There is something common here. I can divide a 5 out of each one of those. So I'm going to divide that 5 out, and when I divide it out of here, I'm left with an x. When I divide it out of here, I'm left with a -1. Now on that denominator, once again, I'm going to look to see if there's something common I can divide out, and there isn't. So once I decide that there isn't, I'm going to set up my double parentheses. And remember, I'm going to look at this back sign because it's going to cut half of my guesswork and take care of half my guesswork, cut it in half. So that back sign being a minus means that I'm going to have opposite signs. One's a plus, one's a minus. So I'm going to take this first term, I'm going to split it up into those first slots. I'm going to take the back term and I'm going to split it up into the second slots. Now there's lots of ways to, well, there's only two ways to split up a 49. It's a 49 and a 1 or a 7 and a 7. But if it'll split evenly 9 times out of 10, that's the way to do it. So I'm going to give that a shot, and if it doesn't work, I'll try something else. I'm going to check my outsides and insides to see if they will in fact cancel because I don't have a middle term here. So out here I get a negative 7x, in here a positive 7x. In fact, those do cancel. I needed them to cancel because I don't have a middle term. So that's factored correctly. Now I'm going to take a look at this numerator, which doesn't factor. There's nothing common that I can divide out, and I certainly cannot set up a double parentheses. So now I'm going to take a look at this denominator. Again, nothing common that I can divide out, so I'm headed for that double parentheses. And like before, I'm going to take a look at this back sign to eliminate half my guesswork. Because it's a minus, that means my signs are going to be opposites. One's a plus, one's a minus. So I'm going to take the first term, I'm going to split it into those first slots, and the only way to split up an x squared is as an x and an x. Now I'm going to take my 2 and split it into the back slots. The only way to split up a 2 is a 2 and a 1. So I'm going to throw it in there and just see what happens. So now when I check my outsides, I get a negative 1x. Inside, I get a positive 2x. That gives me a positive 1x, which is the right term in the middle. So I know that this is factored correctly. Once I've got it factored correctly, then I'm ready to cancel in those diagonals and cancel up and down before I shoot straight across. So when I look at this diagonal, notice that it does have an x minus 1 in common with this x minus 1. When I look at this diagonal, I've got an x plus 7 in common with this x plus 7. Now I'm going to check up and down to see if anything will cancel. 5 and an x minus 7, nothing cancels there. This is just a 1 now over an x plus 2. Nothing cancels there. So now I'm ready to shoot straight across. So when I multiply straight across, I get a 5 on that numerator, and on my denominator, I have an x minus 7 times an x plus 2. Kind of scrunched up there. Now, and I've said before, it depends on your instructor. I'm going to fix that. That's really bugging me. It depends on your instructor. It depends on your textbook as to whether it's okay to leave that denominator as an x minus 7 times an x plus 2. It just depends. I was always taught this is not simplified because there are parentheses in that denominator. So I was always taught go ahead and FOIL that out. Now if I do FOIL that out, I will get an x squared plus 2x minus 7x will give me a minus 5x. And then a negative 7 times 2 is a negative 14. So for me, back in the old days, that's what my answer would be. But some instructors, some textbooks will be perfectly fine with this. You just need to know what's required of you. So again, hopefully you're seeing that all you got to do is kick it back to multiplication. So let's take a look at one more example, and I think that'll be enough to take care of this for us. So notice in this example, yet again, I have a division problem. And so I know that when it's a division problem, dividing fractions means copy, change, flip. In other words, multiply by the reciprocal of that second one. I'm going to flip that second one. Keep that first one as is. That's what copy, change, flip means. But now I'm back to a multiplication problem, which means I'm going to cancel those diagonals, cancel up and down, and then shoot straight across. But the only thing that will cancel is factors. So I need to factor everywhere that I possibly can. Now this will not factor, so I'm going to leave it alone. This denominator, I can divide a 5 out of each one of those. And remember, you always, always, always look first to see if there's something common that you can divide out. When I divide the 5 out of here, I'm left with x. Divide the 5 out of here, I'm left with minus 3. Now, on this one, I can divide a 7 out of each one of them. So I always, always, always divide out what I can. So 7x divided by 7 is x. Divide a 21 by 7, I get a 3. So I have factored as much as possible. Now I'm ready to check those diagonals. Notice on this diagonal, they both have that x minus 3 in common, so I'm going to cancel that out. On this one, this is what throws people off. They're so used to looking for those common parentheses, they get the hang of that, and they forget the small things like this. For instance, 4 goes into 4 once, 4 goes into 8 twice. In addition, I can cancel an x out of here with one of the x's here, and I'm left with an x down there. So I have canceled on those diagonals. Now it's time to look up and down. I have a 1 and a 5, nothing cancels there. I have a 7 and a 2x, nothing cancels there. So now I'm ready to shoot straight across. And remember, I've told you guys before, that checking up and down, that ensures that when you multiply straight across, it will be simplified. You won't even have to think about it or even try to simplify it. I guarantee, cancel those diagonals, cancel up and down. Before you shoot straight across, I promise 100% of the time it will be simplified. So 1 times 7 will give me a 7. And then on that denominator, 5 times 2x will give me a 10x. I don't even have to think about it being simplified because it's there. Now, we need to double check something. And it's this idea of restriction on a domain. Remember, the restriction on the domain says I cannot have a 0 in the denominator of my fraction. But let's go back to that first example because we've got some strange things happening with these denominators. Take a look first in this example, and I'm going to erase up here so that we've got a little bit of room to write about this. In this first example, I have a denominator right here, but I also have a denominator right here. I need to ensure that neither one of those denominators comes up to be a 0, because remember, if I have a 0 down here, this fraction no longer exists. If I have a 0 down here, this fraction no longer exists. So I need to, when I look at that restriction on that domain, I need to say, well, this x squared minus 49, it better not be a 0. And I need to say what would cause it to be a 0. So being that that's a quadratic, I can either factor it, or sometimes what's easier is just to add that 49 to the other side and then just simply take the square root. Now recall that yes, the square root of 49 is 7, but the fact that the square root was not already on the page and I took the square root means I need to consider that plus minus. So this means that x had better not be a positive 7, nor should it be a negative 7. Because if I put a positive 7 here, positive 7 squared is 49. 49 minus 49 creates a 0 down there. If I put that negative 7 in there, negative 7 squared is again 49. 49 minus 49 creates that 0. So here is a restriction on that domain. But recall I also had a denominator down here. Now if that x plus 7 ends up as 0, which I don't want to happen, then that would mean that x had better not be a negative 7, which had already been mentioned right here. So I've got that one covered. But notice what happens here. Remember that when I turn this into a multiplication problem, this fraction flips, creating a new denominator. I need to make sure that this denominator does not become a 0. Now if I'm looking at that, then that means that the x squared plus x minus 2 had better not be a 0. And yet again, in order to solve that quadratic, the easiest thing to do would be to factor if it will factor. If it won't, just use a quadratic formula. This will factor because I did it right here. So I have an x plus 2 times an x minus 1, but that had better not be a 0. So in that case, that x plus 2 had better not be 0. If that's the case, x had better not be a negative 2. The x minus 1 had better not be a 0. If that's the case, the x had better not be a 1. So here's all the restrictions on the domain in that case. X had better not be a plus or minus 7. X had better not be a negative 2, and x had better not be a 1. Anything else is okay. Any other number, whether it be positive, negative, fraction, decimal, even irrational, everything else is fine, just not these two, this one, or this one. Not any of those four numbers. Now let's take a look at that last example and consider that restriction on its domain. Once again, my great concern here is I don't want this denominator to be a 0. So if that 5x, let's see here, it's called restriction on domain. And so like I said, I don't want that 5x minus 15 to be a 0. And if that's the case, then I'm going to add 15 and I'm going to divide by 5. So that x had better not be a 3. That will cause a 0 in this denominator right here because 5 times 3 is 15. 15 minus 15 is 0. But I need to consider this as well, that 7x minus 21 had better not be a 0. So I'll add that 21 to the other side and I will divide by that 7. So x, again, had better not be a 3. Well, I've mentioned it once. I don't need to mention it twice. But remember that when I flip this to turn it into a multiplication problem, suddenly I created a new denominator. So that new denominator I need to consider, the 8x squared, it had better not be a 0. In that case, if I divide by 8, I get x squared equal to 0, which I don't want to happen. And I take the square root, and the square root of 0 is 0, so my x had better not be a 0. So my restriction on the domain is that x had better not be a 3, x had better not be a 0. So hopefully that helps with dividing fractions, or sorry, not fractions, rational expressions. But remember, rational expressions are just fractions. So remember that when it comes to dividing those rational expressions, you're going to copy, change, flip, or you're going to multiply by the reciprocal of the second, and that kicks it back to those multiplication rules, which say cancel those diagonals, cancel up and down, and then shoot straight across. But the only thing that cancels is factors. So you'll have to factor everything to find what cancels. I hope it helps. Have a great day.